Welcome to the last video in this section. This video is all about the different magic methods that we can use inside our classes. Till now we have seen only three magic methods. One was init, second one was repr, and the third one was str. But Python provides many more of these magic methods. So let me try and cover some of the most commonly used magic methods. What I've done is behind the scenes I have created a file called as box, and let us start working with this. As you can see, it's completely empty. So let's create a class, call it as box, and the init method, this box is going to have two sides. So I can say my side A, the type is an integer. Similarly, we have side B, type is an integer. This is going to return nothing. And my instance variables, so my side A is equal to my side A, and my side B is equal to my side of B. So let's create the wrapper method. So you are already familiar with it. I'm just returning a new string called as class of box. Now let me create the str method. So till now there is nothing new to you. Inside my str method, I'm just returning a nicely formatted string saying that this is a box and side A and the value of side B. Let us create two boxes. So this is my first box and this is my second box. Let us also print them out. So I can say print my box first and print my box number 2 as well. So let me save the file and let me run. So till now there is nothing new to you. Let us go back. Now suppose what happens if you do something like this. I want to add both of them together. So if I say b1 plus b2 is equal to my b3, and then I want to print my b3. Let us save and let us try to run this file and see what's happening. It's saying that this is an unsupported operand, and that's because Python does not know how to add one box with another box. But we can implement this functionality by using different magic methods. So if you go back and if you say minus, again if you try to run, again we have some sort of an error because Python does not know how to minus these boxes. And the same thing will happen for all of the different operations such as multiplication, division, less than, greater than, less than, equal to, greater than, equal to, and so on. But what we can do is by using different magic methods, we can implement this functionality on our class. So let's see how we can do this step by step. The first thing that I want to show you is how we can use the in operator. So let me give you a small example. This is my IPython shell. If I say O in Octallium, so we get a true. So let us see how we can implement this syntax of in for our box. We can implement this by using another magic method, and the name of this magic method has to be specific, and the name is underscore underscore contains underscore underscore. This takes self as the first argument. The next argument is what we want to check. So let me name that argument as number. For now, let us skip the type and I will come back to it a little later. Let us see what this type has to return. Let us go back to my IPython shell, and here you can see the return type is of the type of Boolean. So that's what is going to be the return type. So this function is going to return a Boolean, that is, it has to return true or false. The logic for this is pretty simple. Let me again go back to my IPython shell and let me show it first over here. Suppose we have a list, so let me call it as L, and this is 1, 2. Now if I say 1 in my list of L, we get the answer of true. If I say 3 in my list of L, we get the answer of false. So what we can do is we can simply create a list of both the sides, so side 1 and side 2, and we can simply compare that the other argument is inside that list or not. So let's see how to do that. Here we can simply say return if the given number is inside my list, and I can say the first list member is my self dot side of A and my side of B. Now this method works, but this is not foolproof. What happens if this second argument is not a number? If someone provides a boolean value or some other value, then how we can say the user that we have an error? So for this, let me show you some new syntax. So let me go down, let me put a comment. Now if you remember, when I was teaching you about classes and instances, we used one method which is called as isInstance, and there we could check if the dog is an instance of animal, if the cat is an instance of animal or not. So we are going to do the same thing right over here. We are going to check if this number is of the type of integer or not. If this number is not of the type of integer, then we can simply throw a number. So here what we can say, number, it can be any object. We don't know beforehand what the user is going to provide. So object is a generic term, and if you remember, everything inside Python is an object. So we can say number could be any object. And now let's try to see if the number is an integer or not. So we can say if, then we can use the inbuilt function called as isInstance. Then we can say is my number an instance of my integer, and if not, so let me go up and I can use the word if not. Here I want to throw an error, so I can say raise not implemented error. Now since this number is not the type of an integer, we don't know how to do the comparison, so we simply raise an error. In the next section, I'll be teaching you more about errors. Right now, just try and understand if in a situation we don't know what to do, we can simply raise an error. So that's what we are doing right over here. Let me save it and let me show you it in action. So we don't want this one. Here I can say is 4 inside my box of 1, and I can also say is 6 inside my box of 1. Let me save it and let us run this file. So here we have the output. Let me take it up. 4 in box number 1, yes, and that's true. 6 in box number 1, false. Let us see what's happening. So this is our box number 1. We don't have a 6 over here. Now watch closely what happens if I write something like this. I can write A over here. Let me save it and let me try to run it. And this time we get an error, and this error is of the type of not implemented error. And that is what we have coded. If you go back to our line number 15, since A is a string, but we want an integer. So what's happening is in this line, we are raising an error. If you try to evaluate isInstance number is a type of instance, it's going to fail because here the number is actually the string of A. So if not an instance of integer, then we want to raise an error, and that's what we are doing. So if we just open up the terminal, we are throwing an not implemented error. So this error, which is called as not implemented error, so this is a standard way of throwing an error inside this method. Let's see some other operators. So if I want to say is my box 1 is equal to my box 2, let us see how we can do this syntax. Right now, let me take it out. And since this line is always going to fail, let me take it down and let me comment it out. So let me go right over here, and I want to copy and paste till this one. Let me go down and let me paste. Since we want to see if both the boxes are equal or not, the magic method is called as equal, short form EQ. Let me write the proper documentation. So this checks if both the boxes are equal or not. And this line is the standard check that we want to have. Now let's see what to do right over here. This time we expect a box. So let me change the name of the variable from number to a box. Let me go down. So this also has to be box. Here we want to check if the given object, which we call as box, is an instance of the class of box or not. So instead of integer, this has to be my class of box. So if the another object is also a box, only then we can have a comparison. But there is a small limitation of Python. We can't use this syntax directly, but we can use a small hack. And let me show how we can do this. Again, let me go to the top and I can say from my future, I want to import my annotations. And now we can use this syntax, which is right over here. Now let us see how we can compare both of the boxes. Now what happens is the box has a side A and a side B. If both of the boxes has to be equal, that means both of the sides should match. So that's what we are going to say right over here. I can say that return self dot side of A is equal to the box dot side of A. Maybe we can rename this variable. We can call this as the other, or we can say the other box. Right now I'll just write this as other. So right now we are comparing the self dot side A with the others side A. Similarly, we also need to compare the side B as well. So here I can say I want my side A to be equal and I also want my side B to be equal. So I can say self dot side B has to be equal to the other dot side of B, and this also needs to be changed from box to other. So let us go down and here we can say I want to print if my box 1 is equal to my box 2. Let me save this and let me run this file, and here we have the output false. Box number 1 is not equal to box number 2. Let us go back and let us try to implement some other methods. Let us try how we can check for less than and less than equal to. So what I mean is how we can implement this behavior b1 less than and b2 or less than or equal to b2. So let us go up right over here and let us start creating our method. Let me copy till this line and let me paste it over here. So whenever we say that we want to compare if it is less than, the magic method is called as LT, which stands for less than. Let me also write the proper documentation. So instead of this, we want this one. Now let's check if the other box is smaller or not. One simple way of doing this is by calculating area, or you can also use this syntax, but I think using the area is a much more cleaner method. Now since we already have the side A and B, we can define a property for area and we can use that property right over here. So let me go over here and let me create a decorator for my property. I can say this is for my area self and this returns an integer. So I want to return my side A multiplied by my side of B. Now this makes things much more simple. So here simply what I can do is I can go right over here and I can say return self dot area, is it less than the others area, and that's it. Let me save my file. But what happens is this magic method is only for less than. We also want to compare for less than and equal to. So if you go to this line number 44, we have an equal operator as well. So let's see how we can implement that, and that's pretty simple. Let me just copy all of this and paste it. Now this magic method is called as less than or equal to, that means L and E, and on this line we simply have to add equal to, and that's it. So let us start printing all of these things. So let me go down over here. Here I can say I want to print if my B1 is less than B2. One more beauty of this magic method is we have simply defined a magic method for less than and less than equal to, but Python can infer how to implement greater than or greater than and equal as well. It simply has to reverse the logic, and Python does it behind the scenes. we don't have to create another methods since we already have these two methods in place. So here I also want to check if my box of 1 is greater than my box of 2. We can also use the less than and equal. So we can say if this is my less than or equal, and we can also use the greater than and equal. So this one, let me take out this line, let me comment all of this, let me comment all of this, and let us try to run this one. So here we have the output. Let us check if the output is true or not. The first one is my box number 1 less than my box number 2? Let's see what's happening. 3 multiplied by 4 is 12, 2 multiplied by 5 is 10. So that means my box number 1 is larger than my box number 2. Let's see the statement. So this is exactly opposite. My box number 1 is larger, so this becomes false, and that's what we have over here. In the second line, yes, my box number 1 is larger, so we have the output of true, and so on for the line number 53 and 54 as well. Let us go back and let us see some other methods as well. Now let us see how we can implement some basic operations such as addition, multiplication, division, and so on. Luckily, writing all of those methods is just a matter of copy and paste. So let me show you. First, let us create a method for addition, so where we can add 2 boxes. Let me copy and paste. Since this is for addition, the magic method is called as add. Let me change the documentation, and let me also get my spacing right. And here we simply have to add the areas. That's it. Let's check what's the error. Oh yes, now it's saying that it got an integer as the return type, but it is expecting an boolean. So let's see what's happening. Oh yes, here we have written boolean as the return value, but that's not what is happening. Area is an integer, so let us update this from boolean to an integer. So you see, there are so many benefits of having a very well typed code. Let us implement other methods for subtraction, multiplication, and division as well. Let us create one for subtraction, and since it is a subtract, we can say that this is subtract. Let me change the documentation, and this becomes minus. Let us do for multiplication, and since this is multiplication, this becomes MUL for multiplication. Let me change the documentation, and this becomes multiplied. The next one for division. Now this becomes a little tricky. If you think for division it would be just div, you are partially right, but that's not what is happening. Let us go back to our IPython shell and let me try and explain what's going to happen. So suppose if I say 1 divided by 2, we have the answer of 0.5. This is called as true division. Now if I say 2 divided by 3, we get an answer of 0.6 as well. Again, you can see this is a true division. But if you watch closely, we have 2 integers and the output is a float. What happens if we want to have the output as an integer as well? In that case, we have to use / and then 3. So this syntax is called as float division, and this syntax is called as a true division. The return value of a true division is always a float, and the return value of float division is an integer. So let us go back to our code and see how we can do this. The first one can be our true division, so I can just say this is my true division and this becomes my true division. Now remember that the return type is going to be a float this time. Since this is going to be a true division, let me copy and paste this for our float division. So here I can say I want to have my float division, and here I want to have one more slash, and that's it. Let us go and let us print out all of these things. So let me go right over here and let me put all of my print statements. Let me comment all of these things out and let me try to run this file, and here we have the output. So b1 minus b2 is 2. Let us check if that is the case or not. So the area of first box is 12, the area of the second box is 10, and that's what is happening. So 12 minus 10, we get the answer of 2. And if you check the answer of all of the other methods, obviously all of them are going to be right. When I was going through the code, I realized that we have a small mistake. It's not really a mistake, it is just about following the best practices of Python. So let me try and explain. Everywhere we are trying and throwing this error called as not implemented error, which is absolutely fine. But the guidelines in Python suggest that whenever we have a binary operation, that time we simply have to raise an error which is called as not implemented. So this and this are two different things. Please keep that in mind. So let me rectify all of these things. So let me just copy and paste it everywhere. So all of this, let me do my multi-select. This becomes my not implemented, this one and this one as well. So let me save the file. What I mean by a binary operation. So all of these operations, minus, plus, multiplication, division, etc. all of these are called as binary operations. But this one, when we are checking 4 inside B1, this is not a binary operation. So in this case, we are using not implemented error. And whenever we have a binary operation, at that time we are using just not implemented. Well, that's it for this video. And now we are officially at the end of this section. And I will see you in the next section where I will try and expand your knowledge of error handling in Python.